Hello, this is SWATHIRAMYA, Assistant Professor AIDS Department from SNS College of Engineering. You're with me in NLP lecture series. In this lecture, we are going to discuss about the ChatGPT and how the ChatGPT is going to work with NLP. Okay, before discussing about their concepts together, let's see the overview of ChatGPT, how the ChatGPT works. So first thing we are doing is, first thing we are going to look into the transformer architecture. The transformer architecture is the base for ChatGPT. It is a heart of the ChatGPT. Transformer architecture uses a deep learning model to handle the sequence of data, making them well suited for natural language processing tasks. Okay, it's a heart of the ChatGPT. The transformer architecture consists of encoder and decoder layer, each composed of multi-head self-attention mechanism and feed-forward natural networks. These components enables the model to capture the long-range dependencies and generate conceptual related responses. So the heart of the ChatGPT will be the transformer architecture. Okay, it will give you the base for everything. Response to analyze the text what we are giving, and from that analysis it will generate the response. So this is the main component of ChatGPT. Then let's see what is self-attention mechanism. Self-attention is a mechanism that allows the model to weigh the importance of the different words in a sequence. When generating representation, it has to calculate the attention scope between all the parts of word in a sequence and computes a weighted sum, capturing the relationship and dependencies between two words. See, what this mechanism will do is, it take two words and it will analyze and it will calculate. Through the calculations, it will try to understand the dependencies of two words, how the words has been dependent for each other. So through the calculations, it will do that. Okay, it's a multi-headed attention, a variant of self-attention used in the transformer, allows the model to attend the different part of input sequence simultaneously, which enhances its ability to capture the diverse conceptual informations. Okay, so the self-attention mechanism, basically what it does, it takes the two words and it's try to calculate the score between these two words to understand the dependencies. From the score, we can able to understand the dependencies of these two words. So with the help of these dependencies, we try to analyze the conceptual things of the two words. This is the base of the self-attention mechanism. Then what we do is, obviously, tokenization. The word the tokenization you've been heard in the NLP. So this have the NLP and ChatGPT has been connected. See, the basic process will be more dependent on NLP. So there comes the thing. Tokenization. Next, initially we have been reading the two components of ChatGPT. The next component will be the tokenization. Before processing the text data, ChatGPT tokenizes the input sequence into discrete tokens such as the words or subwords using a tokenizer. Tokenization is it's essential for converting the raw text into the numerical representation that can be processed by the model. So ChatGPT typically employs the byte pair encoding, that is BPE. It is called BPE, which is byte pair encoding, or it can use a different kind of tokenization technique to handle out of vocabulary words and efficiently represents the vocabulary of the language. You know what is tokenization? In NLP we have been discussing what is tokenization. That was the actual thing the ChatGPT will be using here. Okay, it breaks down the sentences into small words to try to understand its actual meaning as well as the context meaning. Okay, this is the next component of ChatGPT. Next, what it will do, it will go for positional encoding. Since the transformer do not inherently understand the sequence order of tokens in a sequence, you need a positional encoding is added to provide the model with the information about the token positions. It has to be divided into small tokens, and we need the position of the tokens to understand the sentence. That's what we are doing, positional encoding. Positional encoding is usually implemented as a fixed length embedding added to the input embedding of each token. Okay, these potential embedding encode the relative position of the token in the sequence, allowing the model to differentiate between the token based on their positions. As I told, we have been break down all the sentences into small words, and the position of these words in the token is needed. So that's what we are doing. This is a very simple thing, positional encoding. Okay, with this I'm winding up this session, and the remaining thing will be discussed in the next session. Thank you. See you.